We're going to practice finding the vertex of the graph of quadratic functions. So we're going to start with this one. We're going to find the vertex by writing this equation in standard form. Remember that standard form would look like this. F of x equals a times x minus h squared plus k, sometimes called vertex form, because when it's written in this form, the vertex is hk. So let's transform this equation into this form. So that does require that we complete the square. So let's do that. We'll have f of x equals, and you know that we need the coefficient in front of the quadratic term to look like a 1, so we're going to factor out the negative 3. And that would leave x squared plus 10x. And then we're going to leave some space. And by the way, I'm just factoring out the negative 3 from these first two terms. I'm just going to slide the negative 17 over here. It's still on the same side, but it's just out of my way. I'm going to leave some space right here for the term that I do want. And now we calculate the number that we need to complete the square. Remember, we take half of the coefficient of x and square it. So half of 10 is 5. 5 squared is 25. So it's 25 that we want to add right here. So let's put in the plus 25. But keep in mind that 25 is being multiplied by that negative 3. So in fact, what we have just done is added negative 75 to this side. So since we added negative 75 here, we're going to add 75, so the net change is 0. Because if you add 75 and subtract 75, we've essentially added 0. Now we write it in standard form. We have f of x equals negative 3 times, this is our perfect square, x plus 5 squared plus, 58? And now it's in a form where the vertex is just looking at us. We know that the vertex would then be the opposite of this number right here. So the vertex is at negative 5, comma, 58. So if we were to graph this, we know that the vertex would be up here, negative 5, 58, with the graph opening down. Remember, if the coefficient of the quadratic term is negative, it'd be opening down. If we wanted a nice accurate graph, we'd do more, find the intercepts, but we know it looks something like that. Okay, let's continue. Because sometimes people talk about finding the shortcut for finding the vertex. In other words, what's the formula for finding the vertex of a parabola? And in order to do that, let me remind you about this. If you're looking at a parabola, and suppose we have x-intercepts of, let's make it 3 and 7. Right? We know because of the symmetry for a parabola that the x-coordinate of the vertex would be exactly halfway between that 3 and 7. In other words, the average of the 3 and the 7. So if you average 3 and 7, we'd add 3 plus 7, that's 10, divided by 2 is 5. So 5 is dead center between 7 and 3, and you can see that because 5 plus 2 is 7, and 5 minus 2 is 3. So guaranteed, if we were going to graph this parabola, the x-coordinate of the vertex would be 5. I graphed it with the vertex being below the x-axis, but it could have been above. We didn't even have an equation to look at. But I wanted to remind you about this. The x-coordinate of the vertex would be exactly halfway between the two x-intercepts. So that brings me to the equation in general. We know that a quadratic function can be written like this. I'm going to fix that. f of x equals ax squared plus bx plus c. So here's our generic quadratic function. Let's start by finding the x-intercepts. Remember, to find x-intercepts, you always set y equal to 0. So I'm solving this equation. And we don't have any numbers, but that's okay. We know that the solution to this equation can be generated using the quadratic formula. So we have the x-intercepts are at the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So let me draw that graph. We don't have any numbers, but we have a representation of our x-intercepts. We'll put one of them over here. How about this? Opposite of b over 2a plus the square root of b squared minus 4ac all over 2a. And notice I separated it. I just wanted to make the point that we have this opposite of b over 2a plus this quantity for this x-intercept. And over here, we would have the opposite of b over 2a minus that same quantity of b squared minus 4ac divided by 2a. So if we wanted the point that is exactly halfway between those two, it would be right here at opposite of b over 2a. Because from here, we would add square root of b squared minus 4ac over 2a to get here, and we would subtract square root of b squared minus 4ac over 2a to get here. So our x-coordinate of our vertex is right here at the opposite of b over 2a. So our parabola could look something like this. And again, we don't know if the parabola is opening up or down because we don't know if a is negative or positive, but that's okay. Now I want the y value that would go with this x coordinate. Well, anytime we know the x value and we're given a function, we can substitute that x value into the function. So if you substitute negative, or the opposite of b over 2a into this function, you would have f of the opposite of b over 2a. And we have a formula now for the vertex. So let's write it here. So the vertex would be the opposite of b over 2a, comma, f of the opposite of b over 2a for any quadratic function. So let's look back at the problem that we'd started with. It was this one. Remember, we did this problem by completing the square to find the vertex? Well, let's look at it again. Here it is. And we're going to find the vertex now using this formula. So the opposite of b over 2a for this quadratic function is opposite of b. B, remember, is the coefficient of x. Negative 30 over 2 times a. A is negative 3. And we can do the arithmetic there, and we would have negative 5. Now the y-coordinate of the vertex we'd find by substituting opposite of b over 2a into the function. In other words, we're substituting negative 5 into the function. So we have 3 times negative 5 squared minus 3 times negative 5 minus 17. And if we do the arithmetic there, we should come up with 58. Right? Is that correct? Let's see. We'd have 75 plus did I mess up somewhere? 75 plus 150. 3, 75 plus 150. I think I have a sign mistake somewhere. Where is it? I wish you were here to help me find it. Positive, let's do it. 3 times 25 is 75, plus 150 minus 17. And we're not getting that value. Where's my arithmetic mistake? Oh, I found it right here. It's a negative 3. Right here. Negative 75 plus 150 minus 17. There's our 58. Because I knew absolutely we should get the same answer we got doing it the other way. So the vertex is at negative 5, 58. And if you look back in your notes, you'll see that's the exact same answer we got doing it.